Welcome back for Chapter 6, Lesson 3, talking about polynomials. So the objective for today is to classify polynomials and write polynomials in standard form, and then also to evaluate polynomial expressions. So there's a lot of terminology in these objectives, and we're going to go over that today. So just so you kind of get an idea, this section is a big vocabulary section, and I just want to look at all these vocabulary terms that we're going to be talking about today, so you just kind of get the gist of what this section is about. It's not that it's very difficult, it's just a lot of vocabulary and then what that vocabulary means in reference to algebra. So monomial, degree of a monomial, polynomial, degree of a polynomial, standard form of a polynomial, leading coefficient, quadratic, cubic, binomial, trinomial. Those are all of the vocabulary terms that we're going to discuss today. So let's get started with the first one, monomial. Mono, if you know mono, that means one, okay? And so a monomial, let me get this right here. Okay, a monomial is a number, a variable, or a product of number and variables. Product means they're multiplied by each other. So that's numbers and variables multiplied by each other. So a monomial can just be a single number like 7. 7 is a monomial. It can be a variable like x or y, that would be a monomial. Or it can be a product of numbers and variables. So it could be something like negative 7xy squared. We have a number, negative 7. We have x, y squared. They're all multiplied by each other. This is a monomial with whole number exponents. Okay, so the numbers have to be whole numbers. Okay, so what does that mean? A whole number is 0, 1, 2, 3. Okay, so we talked a lot about exponents. So a whole number is not a negative number. So that means you can't have y to the negative 2 because that is not a whole number in the exponent. So that doesn't work. Or we just got done with fractional exponents. So something like x to the 2/3 power. 2/3 is not a whole number. So that does not work as a monomial either. So the exponents have to be positive whole numbers. So they can be 0, 1, 2, 3, and so on. But they can't be negative numbers and they can't be fractions. All right. So let's look at some different examples of monomials versus non-monomials. So 5, that's a lovely monomial. It's just a number, right? X, a beautiful monomial. It's a variable. Negative 7xy, that is a lovely monomial. There's a number, there's variables, they're all multiplied by each other, so that works. Here we have a decimal 0.5x to the 4th. This decimal works because the exponent is a whole number, okay? So you can have a decimal or a fraction as a number, or even a negative number as a number. It just can't be in the exponent, okay? Do you guys see the difference about these? This negative number was in the exponent. This negative number is not in the exponent. This fraction is in the exponent. 0.5 is not in the exponent. So this is considered a monomial. Some things that are not monomials, right here. Why is this not a monomial? Well, it's because there's a negative in the exponent. That's why this is not a monomial. What about this, 4x minus y? Okay, we're looking at that whole thing, right? This is not a monomial because a monomial has to be one thing. It would have to be 4x times y, and they're not related through multiplication. They're related through subtraction. So anything that's related through subtraction or addition is not a monomial. What about this one, 2 divided by x to the 3rd power? Well, the x to the 3rd power is in the bottom, and if we rewrote this, we could rewrite it, and it would be x to the negative 3, which would be a negative number in the exponent, and you can't have that. So you can't have any variables in the bottom of a fraction or in the denominator, okay? All right, let's talk about, so those are monomials, looking at monomials versus not monomials. Now let's talk about the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. A constant has 0. So a number, that's called a constant. So any number is called a constant. So 5, that has a degree of 0, okay? Another constant, 12, is a lovely number. It has a degree of 0. Negative 8, it's a lovely number. It has a degree of 0. Any number has a degree of 0, okay? Let's look at this next one here, x. What's the degree of that one? Well, we have to look at the exponent. What number is in the exponent? Well, there's no number there, but we know that when there's no number, there's really a 1. So that means for this one, the degree is equal to 1. Okay, let's look at this one. So here we have negative 7, x, y. So there's a 1 in the x, and there's a 1 in the y. So for the degree, you just add the exponents. So 1 plus 1 is 2, which means the degree for this one is 2. And then lastly here, there's a 4 in the exponent, so that means the degree is 4. All right, do you understand that? Perfect. Let's go ahead and look at a few examples. So what these problems are asking us to do is just to find the degree of each monomial. So let's get started. We have 4p to the 4th q to the 3rd power. So we're just going to look at the exponents. There's a 4 and there's a 3. If you add 4 plus 3, you get 7. So the degree of this is 7. Okay, let's look at this one. 7ed. Well, we have to look at the exponents. There are no exponents, but oh wait, there are. There's a 1 here and there's a 1 here. You add those, 1 plus 1 is 2, which means the degree is 2. And lastly, we have 3 here, and it's a constant, which means it's a number, so we know that the degree is 0. All right, you got it? Okay, now it's your turn to check it out with A, B, and C. Here's my friend. You're just going to find the degree of each monomial. Here's my friend the pause dragon. Remind you to pause your device. When you get done, press play, and we'll go over the answers together. All right, see you in a bit. Okay, let's look at this first one and see how you did. So we want to find the degree. We have to look at the exponent. So here we have exponent 2. We don't really worry about the number, okay? The number's just there. We have an exponent of 2. And here there's an exponent of 1. So 2 plus 1 is 3. So the degree is 3. So if you got that one right, great job. Okay, let's look here. The degree of the number, right, is 0. The degree here is 1. 0 plus 1 is just 1. So this has a degree of 1. So if you got that one right, wonderful. And lastly, here the number has a degree of 0. C to the 3rd power has this is a 3. So 0 plus 3 is 3. So we have a degree of 3. So if you got all 3 of those right, great job, and I'll see you in a little bit for the next example.